right, everybody. Well, it's really nice to have all of you here with us. Let's jump into our very first question. What we're going to be talking about today is the inverse of the exponential function, the logarithmic function. So we're going to have a look at some questions on log functions. The first one that I want us to have a look at is this particular question over here. And we have been told that we've been given the exponential function g of x equals a half to the x. So before we get started on answering this question, we need to clarify whether this particular exponential function is an increasing function or a decreasing function. We do not have a diagram to refer to. So we actually don't know what this graph looks like, but we should know, all right? So these are our two options, if you recall from our lesson last week. So either it could be an increasing log function, exponential function that looks like that, or our other option is that it is a decreasing function, in which case it would look like this. So I'd like to know from you guys whether it is the pink graph or whether it is the blue graph. So the exponential function g of x equals a half to the x, pink or blue. Okay, so a lot of you are saying it is the blue graph. Cool. Nice. Okay, well, that's half the battle won. All right, well done. So we know that it is the blue graph. It is not the pink graph. It is going to be the decreasing function. So well done to all of you that said blue. Perfect. First question they're asking us is to write down the range. What do we think the range of this particular function is? Can anybody tell me what I should be writing here? What is the range of this function? You're welcome to put it into the chat if you want to, but it's always awesome to hear your voices. So if anybody wants to unmute, what's the range of this function? What's the range? There we go, Claugie, quite right. Okay, y is greater than 0. Good stuff. Okay. So 1 mark for the answer there. Next question, determine the equation of the inverse of g in the form y equals. So can anybody tell me what we should be writing over here to get 2 out of 2? What should we be writing? You're welcome to unmute and speak. It's always good to hear your voices. What should we write here if we want to get 2 out of 2? Yeah, so how are we going to write the inverse? What would I actually write on the page? Nolutando, go for it.
Hi, ma'am.
Hi, Nolutando.
Okay, so firstly, you're going to write y is equals to the original function that they gave us. So y is equals to a half x.
Cool,
And
keep
then you're
going.
going to swap x and y. So it's going to be x is equals to a half y.
Nice.
And then, therefore, log. And then half is going to be like written at the bottom, and then x.
Good, well done. Very nice. Brilliant, brilliant, brilliant. Perfect. Okay, thank you so much, Nolutando. That was an awesome answer. All right, so a mark for interchanging and a mark for your answer like that. Okay, excellent. Good job. Now they ask us, yes, Intlafazzo, let's see who else. Klogi, yes, Yanela. Yes, okay, so all of you that have put answers into the chat there, that's perfect. No worries, Shane. It's always difficult with load shedding, changing over at 6 o'clock when our lesson starts. Okay. Is the inverse a function? Can we justify our answer? So what do you guys think to that? Is it yes or no? And what's the reason? Is the inverse also a function? What do you think? Yes, I agree. It is a function, quite right. Yes, 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 yes. Okay, so now if we just say yes, that's not enough. We have to justify our answer. So we're going to say yes. What's the reason though? Okay, because we're going to get 1 mark for yes and another mark for the reason. So what's our reason? Cool, it passes the vertical line test, 100%. It's a one-to-one function, 100%. Okay, so any one of those is fine. It's a one-to-one function, or it passes the vertical line test. It doesn't matter. Okay, the other thing we could say is that there is a unique x for every y, but that's really just another way of saying it is a one-to-one function. Okay, good job, everybody. So now we've got another 2 marks over there. So I wanted to include this question because I wanted you guys to see, you know, in the beginning when we were talking about is it a function or not, you can see that these questions come up. So yeah, this comes out of an end of year paper, as all the questions do this evening, because I wanted you to be able to see the sorts of things they're going to expect you to be able to do in your exams and again at the end of the year. Okay, brilliant. Let's move on and let's talk about these sort of slightly more difficult questions. All right, so the point M with x coordinate A and y coordinate 2 lies on the inverse. The first thing that they want us to do is calculate the value of A. All right, so A is the x coordinate and it lies on our inverse. So what are we going to do for this question? Can anybody tell me what you think I should write? Good, Logie. Yes. How? Where am I substituting in into what, Logie? Nolatundo, you're welcome to unmute and speak.
Hi, ma'am, again.
Hello.
So you're going to use the exponential form of the inverse, that x is equals to 1 over 2y, and then you're going to substitute the value, the m.
Absolutely. So what I'm going to do is I'm going to substitute m into my log function. Okay, so in other words, like you said, your value of 2 is going to be your y coordinate. So we're subbing into this, y equals log half x, because that's our inverse. So 2 is going to be equal to log half x, like so. And I tell you what, let's substitute x as well. We know that that's supposed to be a. All right. Now, can anybody tell me how I would need to solve for a? What is the next step? What would I write? So therefore, a would be equal to what? What would a be equal to? Yes, okay, but where does that come from, Penga? Sure, Tsagofatso. You just got to remember, you got to show you're working out. There we go. Okay, perfect. All right, so it would be equal to a half squared. Okay, so our number is equal to a half squared. Lovely. So therefore, A would be equal to a quarter. Good job, everybody. So again, this is only out of 2. 1 mark for subbing in and 1 mark for our answer, like so. Good. Well done, everyone. 4.4.2, M prime is the image of M. It lies on G. Write down the coordinates of M prime. So when they talk about M and M prime, they're talking about a point and its image. So in other words, the reflection of that point on a function and its inverse. So if the coordinates at M ended up being, what were they? A quarter and 2, the coordinates at M prime would be what? Does anybody know? Okay, so Mihlali, we've gone from log form to exponential form. Okay, so that's why the log isn't there anymore. There we go. All right, so 2 1/4. Quite right. Good, Pigelo. Good, Katleho. Okay, so we would switch them around because remember, a point and its image, it means a reflection. Okay, so M prime is the reflection of M over the line y equals x. Okay, I'm going to say that again. So M prime is the reflection of M over the line y equals x. That's why our x and y coordinates have switched around. Okay, good job, everybody. So now we've got that mark there as well. Will be one accuracy mark for our answer. Now let's have a look at the next question. So here they've told us if a new graph h of x is our graph g of x, x plus 3 plus 2, write down the coordinates of the image of m prime on h. So this is a more difficult question. Kamgelo, do you want to ask a question or do you want to say something?
Hi, ma'am.
Hi, how are you?
I'm okay. Yourself?
I'm fine, thank you.
Could you please repeat 4.4.2? I do not understand.
Okay, no problem. All right, so Techofatso has asked a question. She says, so M prime is on the original graph. Yes, Techofatso, that is correct. So what they're basically saying to you, and I mean, this is what you have to imagine without being able to see the graph, okay, is you have got a log function and you've got your original function. Your original function is the graph y equals, or g of x equals half to the x. Okay, so if we draw it like this, there would be g. Okay, the inverse of this is going to look something like that. Not the best looking graph, but not too bad. That's what our inverse is going to look like. Okay, what they have told us when we go back here is that m lies on the inverse. So in other words, somewhere over here, okay, we have, again, this is going to be quite small for you guys to see, but somewhere over here, we have the point M, all right? And the coordinates at M are going to be 2 and a quarter. This point is going to be reflected over the line y equals x. So it's probably going to lie somewhere over there, right? So there's M prime. So it's a reflection of that point over the line y equals x, which you guys know comes through here. There's your line y equals x. Okay, so it is a reflection of that point. So if m is 2 and a quarter, we would switch our x and y coordinates around. Okay, so that's where it comes from. When we reflect over the line x, y equals x, our x and y coordinates switch around. Okay, let's go back to question 4.5. This question is based on what? What do we call this? When we've got gx plus 3 plus 2, what are we doing to our function? It's a type of transformation. There's a name for it. What do we call it? Matrix, can you remember? Let's have a look what you guys are putting in the chat. Yes, absolutely. It's called a translation or shifting. Yes. Okay, so it is a shift, a translation. What does the part plus 2 at the end mean? So this bit at the end, what's that an instruction to do? What does that mean?
There's a vertical shift.
It's a vertical shift. Okay, so in other words, it is a vertical shift. Up or down, Pagelo?
I think up.
It is, okay, because it's plus. Okay, so
Mhm.
2 up. Good job. All right, now, this bit that I'm highlighting in pink, what does that mean?
That's the horizontal shift.
That's a horizontal shift, absolutely. Are we moving left or are we moving right?
We are moving. We are
This is
moving
the
left.
hard bit. We are moving left, 100%. Okay, good, well done. So it's 3 to the left-hand side. So essentially what they're asking us to do is they're asking us to add 3 to x, which moves us 3 units to the left. Okay, so remember it's the other way around when it comes to horizontal movement. Okay, so when we have x plus 3 inside our brackets, it's actually an instruction to move 3 units to the left. Now, we are working from m prime. Okay, so in other words, we are working from what we calculated in the previous question. So we're working from here, what I've just highlighted in purple, okay, because they've told us to work from m prime. So in other words, we have to take 3 away from 2, and we have to add 2 to a quarter in order to get the new coordinates at m. All right, so that means the x coordinate at our new image of m is going to be what? What is our new x coordinate going to be? Yes, Nolatondo, quite right. That's a -1 is quite right. Okay, and what's our new y coordinate going to be, Matrix? What's our new y coordinate? There we go. Good job. Okay, 9/4. Okay, or 2 1/4. All right, so either which way you wrote that, it does not matter. Okay, lovely. Well done, everybody. Okay, very good. So there we would get a mark for knowing that we've shifted it 3 units left and 2 units up, and then marks on our coordinates as well. Okay, good job. Well done. Now, I just want to answer one question. Ola, just give me 1 second because I'm just going back here. Okay, Mbali. Okay, it's not because of the inverse. Okay, it's normal functions. Okay, so if you remember back to grade 11, if you had a graph, let's say you had a quadratic function and it was in the form g of x equals x plus 3 squared minus 2, okay, in turning point form. That x plus 3 over here means that the graph has been shifted 3 units to the left. Okay, so that's where it comes from. Okay, so it goes back to functions from grade 11. Ola, go for it. What did you want to ask?
Afternoon, ma'am.
Afternoon.
How are you doing, ma'am?
I'm
Ma'am,
fine. How are you?
I'm good, ma'am. Ma'am, may you please explain that part, how you got the new x and y coordinates for?
For m double prime.
Yes, ma'am.
Okay, so they've told you to start with m prime, and they've told you to do a translation of that point. All right, they've asked you to shift it 3 units to the left and 2 units up. So in other words, you're starting with your 2 over here, this 2 here, and you are taking 3 away from it. That's where you get -1.
Okay.
Okay, all right, and then as far as your y is concerned, you're starting with a quarter, and then you're moving it 2 units up. So that's why you'd get 2 1/4, which is the same as 9/4. That's where that comes from.
Okay, thank you very much, ma'am.
Okay, no problem. No problem. Okay, Mbali, what did you want to ask?
Hello, ma'am.
Hi, Mbali.
I wanted to ask about the h of x. So,
Sure.
for example, if it said g open brackets x minus 3 close brackets, so if we're doing the horizontal shift, would it be to the right?
Yes, yes, quite right. Quite right. Yeah, absolutely. And then what you would have done in Bali is you would have taken 2 and you would have added 3 to it. Okay.
Okay.
All
Thank
right.
you, ma'am.
Yeah. Good. Well done. Okay. Very nice. Good job, everybody. Let's go and have a look. How are we feeling? Thumbs up, thumbs down. Are we feeling good? You can just pop it into the chat. Thumbs up, thumbs down. How are you feeling? Okay. Lesedi, while we're just waiting for those thumbs up or thumbs downs to come in. No, sorry. No, yeah, not Lesedi. Lesedi was just responding. Nolatundo, you said, ma'am, what will the equation of the asymptote be for the original graph? Okay, so Nolatundo, your original graph is your exponential function. So the equation of your asymptote will be the line y equals 0. Okay, because it's the x-axis. Okay, no, Lutando, y equals 0. Okay. All right. So now some of you, Tsechofatso, and Zetu, ma'am, why are we subtracting by one and adding the other? Because Zetu, this goes back to what we know about functions. Okay, so this goes back to our work from grade 11. If we are told to do a horizontal translation and add 3 onto x, by adding 3 onto x, you're moving the graph to the left-hand side. Okay, that's what adding 3 does. Okay, so it comes from grade 11 functions. Okay, all right, let's go and have a look. What I'd like to do with you guys is this question over here, because this is just a little bit more difficult. We can always come back to that other question over there. There are some nice difficult questions there for us to do, but let's do this one instead. Okay, so in question 5, they have given us 2 graphs, right? The first graph is g of x equals 2 over x plus p plus q, and the other graph is f of x equals log 3x. Then they give us a little bit of information. They tell us that y equals minus 1 is the asymptote, the horizontal asymptote of g. They tell us that the point B, which has the coordinates 1 and 0, is the x-intercept of f. They also tell us that a point, t and 1, is the point of intersection between f and g, so they intersect at A. The vertical asymptote of G intersects the x-axis at E and the horizontal asymptote at D. So we'll go and have a look at the graph for that. Okay, so the vertical asymptote of G intersects the x-axis at E, so that's this point over here, and the horizontal asymptote at D, so that's that point over there. And OB is the same length as BE. Okay, so OB equals BE. So in a way, by telling us OB equals BE, they are really what they're doing is they're telling us what the coordinates at E are going to be. All right, if we're able to interpret that correctly. Okay, so Pagelo, you're saying, so is Q equal to -1? Yes, quite right, Pagelo. Perfect. Okay, so y equals -1 is the horizontal asymptote of G. That's exactly what it means. All right, lovely. So there, I don't know if you guys want to take a screenshot of that as well, and then at least you can see it in front of you. And then I'm going to pull questions up as well. Sorry, I don't know what's wrong with my eye. It's really itchy. Okay, let's go and have a look at the first question. All right, so they want us to write down the range of G. The range of G. So what do you guys think the range of G should be? The range of G. What is the range of G? Any ideas?
Let's go, my people. Yes, it's pouring on my side. I can't even hear anything. It's rain and thunder.
Where are you in Pretoria?
I'm in Joburg.
You're in Joburg. Oh, okay. All
Yeah.
right. So you got a typical thunderstorm. Okay.
Yeah.
Okay. Pagelo, what did you want to say?
Ma'am, can I say that the range is y is greater than -1?
Okay.
Or
That's
do I
part of
say,
that's part of the answer. It's part of the answer. If you want to say that y is
uh-huh,
greater than -1, then there's something else that you need to say as well, because that's not the whole story. All right. If
y
you
is
are
in,
looking, because if you have a look at this, all right, let me just get my highlighter and highlight it here. Okay. Here is the line y equals -1. There is your horizontal asymptote. Here is your hyperbola. There's its one arm. But a hyperbola doesn't just have one arm, does it? A hyperbola has 2 arms. So that's the other part of the hyperbola. So y is greater than -1 is only half the story. There's another part to the story as well, if we want to say that. Okay. Another way, another thing that we have to say as well. Anybody know what that is? Nolutando?
Hi, ma'am.
Hi.
Can you say that y is an element of a real number, but y is not equal to -1?
That's absolutely. Now, that's the way I would have said it. Y is an element of the real numbers, but y may not equal -1. Okay. The other way that you could say it if you want to, right, is that y is greater than -1 or y is smaller than -1. Okay, that's also allowed, but it's slightly less usual. Okay, so yeah, I would definitely go with the first option. Okay, so y is an element of the real numbers, but y cannot be equal to -1. Okay, because this is a hyperbola. All right, very good, well done. And of course, we would get 2 marks for that. One for this and one for this one over here. Good job, Nolutando. Well done. Next thing that they want from us is the equation of G. The equation of G. All right, so if you recall, I'm going to put it in purple over here. They gave us that G of X was equal to 2 over X plus P, and then here we had plus Q. Now, Pagelo, if I remember correctly, you said in the beginning that the value of Q was equal to -1, which is quite right. So that means you've got Y is equal to 2 over X plus P minus 1. So now, guys, we need to work out what the value of P is going to be. Can anybody tell me what the coordinates, sorry, what the, yes, Nolutando, go for it.
Hi, ma'am. We're going to use that information that they gave us, that OB is equals to BE, to find the coordinates of E, and then which is going to be E is going to be 2 and 0.
Beautiful, lovely, well done. So that's going to be 2 and 0. Very nice.
And then, ma'am, when we sub it back, it's going to be 2 over X minus 2 minus 1.
Lovely, perfect. Well done, good job. Okay, very, very nice. Perfectly done. Okay, so the equation of G for 2 marks, 1 mark on the -1 and 1 mark on the -2. Okay, good job. Well done, everybody. That was perfect. Okie dokes. Let's go and have a look at the next question. So we'll just put it over here. G of X is equal to 2 over X minus 2 because it's been shifted 2 units to the right, minus 1 because it's been shifted 1 unit down. Okay, calculate the value of T. Okay, so T is the X coordinate at this point A over here. All right, so how are we going to work out the coordinate at T? Is there only one way to do it, or could there be 2 ways for us to be able to do it? What do you guys think? How would we work out the coordinate? Because Paseke, because it's been shifted 2 units to the right. Okay, remember they told you that OB equals BE here? OB equals BE. So if OB is 1 unit, then OE has to be 2 units. So the graph has been shifted 2 units to the right. Okay, ideas, how are we going to work out the value of T? Remember, A lies on the log function, but it also lies on the exponential function. So what do you guys think we should do? Okay, so Ola, we don't need to calculate any x-intercepts in this case. No. No, not necessary for us to calculate an x-intercept. Sub into G. Sure. So if we subbed into G, Nolatanda, what would you write if you were subbing into G? Can you tell me what you'd write?
Okay, ma'am, I'll write T. No, wait. Yeah, I'm going to write 1 is equal
Good.
to,
Keep going. You're doing perfectly.
1 is equals to 2 over t minus 2 minus 1.
Lovely. Perfect. And then how would you solve for t from here?
I will take 1 to the other side, the minus 1 to the other side, so it's plus 1.
Mm-hmm.
And then
So
I'll cross multiply.
lovely. Oh, that's beautiful. So now we can cross multiply here. So that would give us 2t minus 4 is equal to 2. And then
And
2t would be equal to how much?
6,
Gorgeous. And then t would be equal to?
3.
Beautiful. Okay, very, very nice. Well done. I'm really, really pleased that you were able to do that so easily. Is it also possible for us to use the equation of f to calculate t, Matrix? Could we also use the equation of f to calculate t? What do you think? Because a lies on g and it lies on f. Do you think we could use the equation f? Yes, absolutely, absolutely. So as an alternative, all right, subbing into this equation here for f, you know that x is equal to t and y is equal to 1. Okay, so you could go here if you wanted to. You could say 1 equals log 3t. And then you could use your exponential form. So your base 3 to the power of 1 is equal to t. Okay, that's even quicker, isn't it? Okay, so that would be a perfectly acceptable way of doing it as well. What was it out of? It was out of 3 marks. You'd get 3 marks for that as well. Okay, so yeah, just as an alternative way of doing things if you wanted. Okay, a little bit shorter, I think, but yeah, that's possible as well. Okie dokie, let's go back and have a look. All right, write down the equation of f to the minus 1, the inverse of f in the form y equals. Okay, so there is our equation f. Let's just write that down for ourselves. So here we are for question
Ma'am,
5.4. Yes.
ma'am, I'm sorry, I had my hand up. I think
Oh,
you did not see.
I didn't see. I'm so sorry. Who am I talking to?
Katleo, ma'am.
Sorry, Katleho. Yes, go for it, my girl. What did you want to ask?
I just wanted to know where you found the one, ma'am. The question before this one.
All right.
I don't
So
understand the one.
that's fine. Here, Katleho, it was given to us. Okay, so at this point over here, we were told that the x coordinate is t, and can you see there, there's the y coordinate, it's 1. Okay, so that's why this one over here, let me just highlight it for you. This one over here, this is what we substituted. So that one over there was this one over here that we subbed in our y. Or if we were looking at this graph over here, our y, f of x, there's our 1 over there. That's where it comes from.
Oh, okay, ma'am.
Okay, it was
Okay.
given. Okay, no
ma'am.
problem, Katleho. All right, good stuff. Where were we? Okay, so we were writing down the equation of f to the minus 1. So somebody's already put it into the chat. That's perfect. Well done. So if this is y equals log base 3 to the x, then switching x and y around, we would have x equals log 3y, and now we would need to make y the subject of the formula. So y would be equal to 3 to the power of x. Okay, which someone told us. I don't know who that was. Oh, Clorgy. Yes, good job, Clorgy. Okay, who else has got a hand up? Kagiso, go for it. What's the question, Kagiso?
Ma'am, do we have to write all of
Yes.
that, ma'am?
No, I'm just being thorough. I'm just being thorough. If you wrote this and this, that would be fine.
Okay, thank you, ma'am.
Okay. All right. Yeah, that's more than enough.
Take
Okay.
screenshots.
Okay. Question 5.5. Now, this is quite an unusual question. let's talk about what it means. So they've said to us, for which values of x will the y on the f minus 1 be smaller than 3? Okay, so for which values of x is the y on our inverse less than 3? So our outputs on our inverse have to be less than 3. For which values of x is this happening? That's what our question means. So let's go back and go and have a look. All right, so here we know that at t, or not at t, but we know that this was equal to 3. So x was equal to 3, y was equal to 1 at that point. So they're asking us for which values of x is y going to be less than 3. Okay, so we know that our equation of our inverse is 3 to the x. That's our y, isn't it? Is everybody happy with that? So in other words, f to the minus 1 of x is equal to 3 to the x. So what I'm doing is I'm taking this and I'm substituting it in place of f to the minus 1. And it has to be smaller than 3. So 3 is 3 to the power of 1. Okay, so that means where x would have to be smaller than 1, like so. Yes, that's it. That's it. Pagela, we all do. We all get questions like this wrong. Okay. But if we understand what it means, then we've got a better chance of being able to get it right. Okay, so again, it's only out of 2 marks, so it's not a massive problem. There we go. All right, now question 5.6. Let's go and have a look at this one. Determine the point of intersection of the graphs of f and the axis of symmetry of G that has a negative gradient. Okay, so first of all, let's work out what the axis of symmetry of G with a negative gradient is. Okay, does anybody know what the equation of this line would be, or how would we work it out? How would we work out the equation of the axis? The equation of the axis of symmetry of G with a negative gradient. Not negative b over 2a, that's how we would work out the coordinates at the turning point in a parabola. Yes, Nolatundo, y equals negative x plus c, that's correct. So its gradient never changes. It's always going to be the line y equals minus 1x. What we don't know are the coordinates at c. Right? This line, this axis of symmetry, it will always go through this point over here, which is the point of intersection of your asymptotes. Do we know what the coordinates at D are? The coordinates at D are what and what?
Two and negative 1.
Exactly, 2 and negative 1. All right, and what was really nice about Nolatundo's suggestion is that we can then take this and go and sub it straight in here. Okay, because it's always going to go through that point. Okay, so if you remember, this first time you would have done this would have been all the way back in, no, actually grade 11 would have been the first time. Well, you would have spoken about the axis of symmetry in grade 10, but you wouldn't have done any shifts. Okay, so this is last year's work. Okay, so negative 1 goes over here, subbing in the x, we've got 2. So that means that C would be equal to negative 1 plus 2. So C would be equal to 1. So the axis of symmetry takes the form y equals minus x plus 1. Right, so that's part of our answer. They want us to determine the point of intersection of f and the axis of symmetry that has a negative gradient. Okay, so if we go back and have a look at our diagram F. Okay, so here is F over here. And the only bit of information that we've got about F, I mean, apart from the fact that it has coordinates A and B, is that here is its x-intercept. right? So we've already worked with this. Why have they told us that its x-intercept is b and -1? Right? What is the x-intercept of this particular graph? If we wanted to work out its x-intercept, we would have to let y be equal to 0. Okay, so if it's x-intercept, make y equal to 0. Take the x over to the other side. So positive x would be equal to 1. So that means that our axis of symmetry has the same x-intercept as our log function. So that more than likely is going to, well, not more than likely, that has to be one point of intersection. Maybe there wouldn't be any others because it's a straight line. But that would definitely have to be it as well. Okay, so what I would do here is I would take the coordinates of D, which we know are 2 and -1. We're going to sub that into y equals -x plus c. We're going to get the axis of symmetry, the equation of the axis of symmetry. So just doing that again. So we know that c was equal to 1. So it is the line y equals -x plus 1. For its x-intercept, make y equal to 0. Take the x over to the other side. And what that means is that, therefore, the x-intercept of the axis of symmetry is where x is equal to 1. Our graph of f also has an x-intercept at 1. So f also has an x-intercept where x was equal to 1. So therefore, B is a point of intersection. All right, and that's how I would have done that question. Okay, so see how that's something that you need to learn. Okay, so when we are talking about axes of symmetry of a hyperbola, so axes of symmetry for hyperbolas, with the one with the positive gradient is the line y equals x plus c. The one with the negative gradient is the line y equals minus x plus c. And then it's your job to work out what the value of c is. Okay, so that's something that you got to learn. You did that in grade 11. Okay, Sihawu. All right, Cabello, you asked a question. Could you use the log equation to solve for t at 5.2? Yes. At 5.2. Okay, so what? Yes. Yeah. Oh no, could you hang on a second, Cabello? 5.2, no, because there they wanted you to calculate or determine the equation of G. So no, Cabello, you wouldn't be able to do that. You could use the log equation in 5.3 to calculate the value of T. I don't know if I'm answering your question, Cabello. Sorry, let me, at question, did you mean question 5.3, Cabello? Okay, the answer to that is yes. Yes, you can. So you could either use the exponential, now, sorry, it's been a long day, guys. Either you could use the hyperbola or you could use the log function. I did it over here. So this bit, I'm just going to draw a pink ring around it. That over there is where I use the equation of the hyperbola. And up here, this is where I used the log equation, all right, to work out the value of t. So yes, I did it both ways. Kamogelo, do you want to ask a question?
Hi, ma'am.
Hi, Kamogelo.
Hi, Could you please go down a bit?
Yes, of
question.
course.
On 5.5, where we are supposed to find the values of x.
Yes.
So when we are looking for those, do we use the equation of the inverse of f?
Correct. Correct. So the inverse of f in this case is an exponential function.
So always, all the time, if we need to like find for which values like f, the inverse of x is less or greater than x, do we always use the equation?
Yes. So in other words, really how we ended up answering question 5.5, we needed 5.1 to be able to do that. Okay, so just like, let me just point this out to you. You probably know this already, but you know that f of x means y, doesn't it? Okay, so it means the outputs or the y's on f. Okay, so this means, so the outputs, okay, or y values on f. If you are writing f minus 1x, that is also y. But what it means is it means the outputs or the y values means the outputs or y values on the inverse of f. Okay, so when we had f to the minus 1 of x was equal to 3 to the x, what I was doing is that where they said to us f to the minus 1 of x is smaller than 3, I was now taking this and I'm substituting it in there. Okay, so I'm saying 3 to the x is smaller than 3 to the 1.
Yes.
Okay.
Yes.
So that's why x would be smaller than 1 in this case. Okay.
Yes. And then, ma'am, my second question is that for the, could you please go up? I'm so sorry.
No, don't apologize. It's fine. Where do you want me to go up to?
To the statement.
Sorry, just say that again too.
Our statements where we like the graphs of.
There you go.
So on the graph of f at x is equals to log 3x, could we be asked to calculate, like, let's say, real roots and things like that? Oh, okay.
No, I don't think so. The other thing that you also need to learn about the log function is that all the log functions that you are going to do are going to have the same x-intercept. So the x-intercept, when you're talking about roots, the x-intercept is always going to be at 1 and 0 for every log function that you work with. They will never ask you, and they won't ask you a question where they combine nature of roots together with that. So
all right,
you don't need to worry about that. Okay.
Okay, ma'am. Thank you.
All right, no problem. Are there any other questions that anybody would like to ask? So Matrix, how are we feeling at this point then? Are we thumbs up or thumbs down? Are we okay? We can just check in with you. Thumbs up, thumbs downs. How are we feeling? Oh, that's good. Okay. All right. So Chloe up and down, Voyo in between. Okay. No, this was a difficult question. All right. This was a difficult question. Okay. So 441, that was this answer over here. Is this the one that you want me to re-explain? Mbali, 441? Okay. All right, let's just go back and have a look at this. Okay, so the equation of our inverse of g is this over here. It's our log function. Okay, so in other words, let's just clear some space here. It doesn't matter if we get rid of this stuff. Okay, so g to the minus 1 of x is log base 2 to the x. Here they are telling us our x coordinate is a and our y coordinate is 2. So we're going to take that 2 and we're going to sub it in place of y. Sorry, it's not that, it's a half. Okay, x. So in this form, as it's written over here in Bali, 2 is your exponent. Your exponent is equal to the log of your base, and then your number is x. So now when we go back and we write it in exponential form, our number x is equal to our base raised to our exponent. So when we square a half, we're saying a half times a half, and that's where we get the quarter from. Okay, that's where it comes from. Okay, so it's a very good question. What you should be careful of is that you should never take any longer than the marks times 1.2. Right, so if you take however many marks a question is for, so let's say a question is out of 3. In order to work out how long you should be spending on that question, you should multiply 3 by 1.2. Okay, and then you'll have an idea of how many minutes you should spend on a question. And again, if you see something and you can't think straight away, this is what I need to do, just highlight the question or put a star next to it or something, that leave it and go on and make sure that you can do the questions that you can answer. Okay, that's really, really important in maths. And I know it's easy for me to say, but try not to be thrown by the very difficult questions. Right, so things like 4.5 are there so that not everybody can answer them. So if you can't answer question 4.5, it's not the end of the world. What's important? Can you do 4.1? Can you do 4.2? Can you do 4.3? You know, could you do 4.4.1? If you can do all of those questions, then, you know, you're going to be able to access at least 60% of the paper. Okay. So don't let it throw you. Come back to these questions and worry about them later once you've done everything that you know how to do correctly. Okay, so 5.6 was another one. So I assume that's this 5.6 over here. Okay, so when we're talking about an axis of symmetry, your exponential function has got two exponential function. Listen to me. Sorry, guys, it's late in the day now, and then I start saying all sorts of things that are not true. Okay, your hyperbola has got two axes of symmetry. Let's just go back, and it's a little bit difficult to see on here because of all this writing. Let me just get rid of all of this. Okay. So the graph that I had highlighted in purple is our hyperbola. Okay, let me highlight it in a different color. So there's our hyperbola. So there's one arm, there's the other arm of our hyperbola. So your axes of symmetry look like this matrix. Let's just get a different color and shapes. So your axis of symmetry goes through the point of intersection of your two asymptotes. So that pink line over there, okay, is the axis of symmetry with the negative gradient. Okay, in its generic or standard form, it takes the form y equals negative x plus c. It's your job to work out what its y-intercept is going to be. Okay, so it cuts the graph in half this way. You also have an axis of symmetry that has a positive gradient. Okay, so let's do that one in green. And it also goes through that point of intersection of the two asymptotes. Okay, so this graph takes the form y equals positive x plus c, because the gradient is positive. Here the gradient is negative. So in this question, they were asking us about the pink axis of symmetry, not the green axis of symmetry. Okay, so the green one cuts it in half this way, the pink one cuts it in half that way. Okay, so that's what an axis of symmetry does. It cuts a function in half, or it's like a mirror line. We can use the fact that the coordinates at D, which are 2 and -1, to assist us. So if you learn this, all you have to do is then go and sub in the coordinates at D in order to work out what C is. So our y is -1, our x is 2, so C is going to be equal to 1. So that means that our axis of symmetry with a negative gradient takes the form y equals minus x plus 1. Then what I did, can you see here, my drawing is almost perfect. Okay, it's just slightly off. This is the point over here. Can you see that its y-intercept is in the same place? Sorry, its x-intercept is in the same place as the x-intercept of f. Okay, so that's what I was doing. I was showing that its x-intercept is the same as the x-intercept of f, and that's why these two lines would have to intersect at that point. Okay, so I worked out the x-intercept of this line by making y equal to 0. I took that over to the other side and I said, there we go. Okay, so in other words, it must also go through this point. Okay, so that's where they have to intersect one another, is on the x-axis. That's what I was trying to say. Okay, for 5.6, no problem. Yes, see how you can do that too. You can learn those rules as well. Yeah. And then there's a different rule for the one, it also involves the P and the Q, but there's a different rule for the axis of for the negative gradient. But yeah, it's the same thing. All right. So maybe your teacher at school teaches you that y equals x plus p plus q. I teach my classes what I think it was Nolutando made this suggestion, if I remember correctly. Kamogelo, do you want to ask a question?
Ma'am, could we please go back to the properties, like up? Could you please
There.
go? Yeah.
All right,
So
that's fine.
the last bulletin says OB is equals to BE.
Mm-hmm.
What does that help us with?
Okay, so the reason why them telling us OB was equal to BE was important for us being able to work out a couple of things. First of all, we needed to know what the equation of this vertical axis, this vertical asymptote was. Okay, so we needed to know the equation of this vertical line. So if they tell us that OB equals BE, we know from O to B it's 1 unit. So that means from B to E it's going to be another unit, isn't it? So that was important to us to know that this was the line x equals 2. If you recall, we used that when we calculated the value of P over here. Do you remember?
Yes, I do, ma'am.
So we said y equals 2 over x minus 2. That's why we needed to know it. Minus 1. That was the one thing, okay? When we had to work out the equation of G. So we needed it here. Then, in order to be able to answer the very last question, we also needed, because we need to know that at D, the x coordinate is 2 as well. Okay, so it helped us for question 5.2 and question 5.6.
Oh, okay, ma'am.
Okay, does that answer your question?
Yes.
All right.